Hi, everyone. I am just going to give you some quick advice on worksheet 2 to help you with it. So here we go. Let me pull it up. All righty. All right, so with this first problem, I would hope that you don't need any advice on the free body diagram. I think the only thing I'll say about that is it's usually a good idea to draw the object. In this case, we're looking at that beam, so draw a separate line for the beam right there and draw all the forces. Part B, identify the best place to set the axis of rotation based on what you'll have to solve for below. And here is the key to that one. You want to put the axis of rotation, which we usually use this symbol, right? The X with the circle, wherever you've got the most unknowns. So like, let's say you've got like, I don't know, a force here and a force there, and they're both unknowns. Put your axis of rotation there, because when you try and do the torque for them, torque, let's call this force A, torque of force A equals 0 because it's a distant 0 from the pivot point. And same thing here, let's call this force B. It would also have a torque of 0. Torque of force B would also equal 0 because it's a distance of 0 from the pivot point. So that's my advice for B. Wherever you've got the most unknown forces, put your pivot point at that location because it'll make those torques 0. The only other advice I want to give you on this problem is for these 3 parts. One of them, well, since we know that this system, the beam and the sine and all of that, is not moving, it's not rotating, so we know that net torque will be 0, so all the torques add up to 0. But because it's not moving left or right, we know net force X equals 0. And because it's not moving up or down, we know net force Y is equal to 0. So I won't tell you which is which, but part C, you're going to solve by using one of these 3. Part D, you'll solve by using a different one of those 3. And part E, you'll solve by using a different one of those 3. So you kind of have to sort that out. I recommend you start by writing all those out. What torques add up to your net torque, what forces add up to your net force in the X, what forces add up to your net force in the Y, and then you can solve. Advice on problem number 2. A 65 kilogram window washer is standing 1 meter from the edge. Okay. Draw a free body diagram, determine the tension in 2 cables. So again, this, right? You want to choose the location of the pivot point. And again, you're going to want to choose a location where you've got unknowns. So those will have 0 torque. And how much torque does a force provide if it acts at the axis of rotation? We know it's 0, right? So yeah, so that same advice there that I gave right here. You want to put the axis of rotation at a point where you've got multiple unknowns, so it'll make those unknown forces 0, or just one unknown. I think in this one you'll have 2 unknowns, so just put it at one of them. And then you can use your net torque to solve. I will say that to solve for the other tension force, so that way you'll solve for one of these tension forces. To solve for the other one, you could move the pivot point, or you could use net force Y equals 0. I personally think that's faster than moving the pivot point. For number 3, all of these, let me show you the slide that I think will help you with that. So it looks like this. Remember, slide number 7 from our class slides, it will help you with problem number 3. Remember, when we find torque, there's 3 ways to solve for torque. We could find the force that's perpendicular times the radius. So if this is, or sorry, not the radius, the distance from the pivot point. So this is the distance from the pivot point, and that's the force. Notice they're not perpendicular. You could find the part of the force that is perpendicular and multiply it by that distance. Or you could find the part of the radius that's perpendicular and multiply it by the force. Or you could take the radius and the force, no perpendicular components, and multiply them by sine of the angle between them. Notice that sine of the angle between them can certainly be more than 90 degrees. All right, there you go. I hope that's helpful. Oh, I guess I will say that means your answers to 3A, 1, 2, and 3 should all be the same. You should get the same answer to all 3 of those. Good luck on worksheet 2. We'll present it tomorrow. See you then. Bye.